Alright, hello there. And I finally figured out what was wrong with my I2c connection on this board. This is a sensor board, and it took me this whole day to actually figure out what was wrong. And there are two things wrong. On one of the I2c buses, I mistakenly soldered a capacitor instead of one of the pull-up resistors. So the effect I was getting was kind of like a waveform that on the SDA line where the capacitor was, it would kind of go down to zero and then slowly go up again. And that was very weird, and I was like, what is going on here? And I would check the schematic, I would check everything besides actually checking the components that were actually mounted and connected to the lines. And it turned out that one of the capacitors was placed slightly to the side where the resistor should have been, and the resistor was placed where the capacitor should have been. So I fixed that, and now actually the sensors are being detected, at least two of them. So the ones that are on I2C1 are detected, and I can actually read the model revision and the module revision and the date that's stored on the sensor. But on the other one, let me see here. I'm just going to bring up KeyCAD. Let's see, KeyCAD. On the other one, there was actually, on the other I2C bus, there was a different problem. And the problem is actually, it was made worse by the fact that I didn't review this board properly. But what actually happened was that PB11, the data line PB11, is actually not available on the LQFP64 package of this STM32F413, and instead it is connected to the VCAP pin. So instead of getting I2C data line, I was getting the VCAP pin, which was at half voltage and was oscillating. So that I2C2 is currently not working, so two of the sensors are not working, but at least two of them are working, so they can be tested. But the other ones, I maybe could somehow hotwire the I2C bus farther to kind of make them work as well. But I'm not going to do that right now because I think that it's going to be a little too much time spent for only marginal benefit in this case. But there was nothing wrong with the power supply. Actually, as you've seen on the schematic, it was on the schematic it said it was 2.5 volt power supply. I actually fit the right regulator on the board, even though on the schematic I had 2.5 volts on the labels. So yeah, this board is complete shit. I'm so not happy with this board. I think that I could have definitely done this particular board better. And what really could have saved the day here was going over the board just like I did on the motor controller, and just looking through every single connection and referencing it with the data sheet. I should have done that, but I didn't, and that's what I get for not reviewing my board. Let's see here. So if I go and open this design here, let's see. So the capacitor that was actually, let's see. I think it was one of these. Actually, no. It was this one. It was this one here. So I placed this capacitor here instead of placing it there when I was soldering the boards. So it ended up pulling down the SDA line to ground over the capacitor. So the SDA line was completely out of whack. Because I was also assembling them at the same time, I did exactly the same mistake on all of them. That's why none of them worked. Yeah. So, putting aside the fact that two of the sensors on I2c2 are not currently available, let's bring up a second board and see if there is anything else that needs to be done here. So let's see. I'm going to connect the data lines. Let's see. So I actually had to also hotwire the I2c level converter, and I think that the level converter is not necessary in this case. It was just, yeah, it was a unnecessary piece of circuitry in this board, because the pins can handle 3.3 volts and seem to do so just fine. And also the voltage is fed through a resistor, through a pullup, so there's not much current flowing. So it's working just fine. The datasheet says 3.6 volts maximum voltage, but the operating voltage is 2.8 volts, which is a little bit of a it's a little bit impractical to have 2.8 volts, because that requires an extra regulator. But I don't want to run this on 3.3 volts because the datasheet says that 2.8 volts supply voltage is recommended. Let's see. Is this the board that actually worked? Or was this? Let's see. Is this one shorted somehow? I'm gonna check the supply voltages on the power supply. Yeah, actually, yeah. This is what I did here. So I removed the regulator. Let's see. Let's grab a different board and see if this one has all the components on it. Oh, this one is also. This one doesn't have the regulator either. Let's see. I have the regulator somewhere. Because another problem with this board was that the regulator for the 3.3 volts was actually in one of these R packages, which has a like swapped out pin out. So I had to order the normal sub 23 instead of the sub 23R, which I ordered at first. So I guess instead of me searching for for some plastic bag with the regulators, I'm just gonna move this regulator from this board onto another board, and then just power this board up. So let's just move it. It's a quick job to move a regulator. And I'm gonna power it on. It's a bit hot. I'm gonna power on the supply slowly, just to make sure that the regulator is okay. Let's see here. So got the regulator there. And we got 3.3 volts, so no problem there. And actually the light is blinking, so all perfect. And let's see, I think we have, I only have one of the sensors mounted here, and I don't have the I2c bypass. So one of the things is that this chip actually has the high voltage and the low voltage side swapped out. So this should have been connected to the low voltage side, or to the high voltage side, and the low voltage side should have been connected here. But the solution that I came up with, just to kind of get this working, is just to hotwire these pins. So this one goes there, this one goes there, and the chip just goes away. So this has some hot wires, and this one has none. So instead of making any new hot wires, maybe I should actually make some new hot wires. Or maybe I shouldn't actually make any new hot wires, because this I2c bus is still never going to work anyway. The I2c2. So I'm just going to remove the hot wires from I2c2 on this card and move it to the other board. Let's see. And the capacitor is in the wrong place, so I'm gonna show what it looks like. I'm gonna show you the waveform that was puzzling me today, and I should have checked the resistors, the pull-up resistors. It was when I started to kind of pull off anything that was connected to that circuitry, to the I2c lines. When I started pulling things off, and I pulled off there are actually two sets of pull-up resistors now, because when I hotwire it, there were like a pair of pull-up resistors on the low voltage side, and a pair on the high voltage side, on the 3.3 volts. So it actually ended up having 4 pull-up resistors. which doesn't really matter because it's 10K resistors. But I started to kind of pull off anything that was connected to the lines, and when I got to the capacitor, I was like, wait a minute, this capacitor is in the wrong place. This capacitor cannot be connected correctly. So I checked how it was connected, and it was connected to the SDA line. So the SDA line was not able to operate properly. Let's see. So this one is going to be spitting out the weird waveform on the SDA line. So once it cools down, I'm going to power it on, and then I'm going to connect the scope to the SDA line. Let's see. For some reason, DS remote has stopped working for me, but pulse view still works. Yep, pulse view still works. And in terms of the firmware, I'm actually going to add this loop back in, because without this loop, it's going to be hard to capture the right at the right time, just to capture this waveform. So it's better if I add back the loop. Let's see, where was it? This was in the loop driver, and it was in there. Let's see. Yeah, and this is actually, let's see, let's restart this terminal. Yeah, so now it's not able to communicate, and it's kind of trying to initialize the communication all the time. So looking at the scope, let's see. What is going on here? Let's see. I need to quit. I need to quit for today. I really need to quit for today. Okay, this is better. This is what it looks like. This is the waveform that was coming out on the SDA line because of the capacitor. So it's kind of trying to initialize communication, but it never gets very far. On the clock line, it actually stops communicating if I connect the scope probe. But it looks like this. So it's kind of trying to communicate, but it can't communicate because of the capacitor. So now I'm going to remove the capacitor, and then I'm going to try again, and it's going to work a lot better. So now I swapped the resistor and the. Actually, I just removed the capacitor because I don't need it. I'm not going to have that chip there anymore, and it was the bypass capacitor for the voltage converter. So now now it should actually communicate. Now we should actually get. Let's see if we get the printout. So. This one. Yep, so 2 of them are working. Once again, 2 are working, 2 are not working. Which is interesting, actually. I think it's quite possible that it's actually the same one that's replying, because I can sort of. I think that's actually the case. So for some, because they all have the same I2c address, I actually need to set unique I2c addresses on all of them before they can work properly. Let's check here. So maybe. Right, I see. So it was actually floating the GPI 0 pin, but it was still working. But it was floating it, so it was the same one that was replying. If I connect this, let's see. Let's see if the diode actually works in this case. So I'm gonna remount the diode. The diode pulls the voltage down, but it kind of ends up being at the limit. So it's not ideal. Ideally, because I'm now using 3.3 volts, also on all of the inputs besides the power, and it seems to work fine. The diode can actually be replaced with just a 0 ohm resistor or something. So now I should select only the one that is mounted, because there's only one mounted on this I2c bus. The other one is on the other I2c bus, and the fourth one is not mounted either. So I think I happen to nudge the sensor a little bit, so maybe it will not communicate. We'll see. So the diode I'm looking at right now is this. Let's look at the schematic. It's the diode that's used for pulling down this chip select line. So when this one is when this one is pulled high by the pull-up resistor, the chip is going to be enabled, when it's pulled down, it's going to be disabled. That's how the GPIO 0 works. Yeah, so now one of them works and gets selected, and the other one that's not mounted is not replying, which it's supposed to do. So that's it. That's it for this video. I'm happy that I solved this, but I'm not happy about my design. I could have been a bit more thorough with this particular design. But there's still a few things that can be tested. So it's not going to be a complete failure, I guess. And I think that it's really like, because I can fix a lot of things myself. It's never really a complete failure, because I don't depend on anybody else to sort of find the problem and fix it, and I don't have to pay anybody any money for doing that. Sometimes I may need to put some of my time, and like this is a day of my life wasted just looking for this I2c problem. But in the end of the day, I fixed 2 of the sensors, and I know what the problem is with the other 2. So it's time to move on, and it's time to get the code ready for these boards, get them tested, and in revision B, I can fix all of these problems. All right, time to finish.